lesson is called Using the Multiplicative Inverse to Solve Equations. Now, we only have one vocabulary term. The multiplicative inverse is the reciprocal of a non-zero number. So what we did when we were dividing fractions, if you remember, is we used, after we changed the operation from division to multiplication, we had to write the reciprocal of the second fraction. Well, that's basically what we're going to be doing now, but this time with equations. Now, if you remember way back from when we first learned about solving equations in the fall, solving the equation involves isolating the variable, step by step, very methodically, taking away each of the numbers that is with the variable so that we can find out what its value is. So we will be using multiplicative inverses in each of our three examples. In our first example, we have a one-step equation, which means there will be only one thing that we have to do to isolate the variable c. Here we have 5/14 c equals 1/2. Well, if you remember, 5/14 here is the coefficient of c. Whenever you see a number in any form, whether it's an integer or a fraction or a decimal, attached to a variable, it means the operation that is happening is multiplication. And the way to undo multiplication is to divide. And if when we are dividing by a fraction, remember, we are multiplying by its inverse. So the way that we're going to isolate the variable c is to multiply both sides by the reciprocal of its coefficient. So we are going to multiply both sides of the equation by 14/5. So I'm going to write 14/5 here times 5/14 c. And because this is an equation, we need to change both sides in exactly the same way. I'm going to also multiply this side by 14/5. And so when I do that over here, the two 5s cancel each other out to make 1s, and the 14s cancel each other out to make a 1. So what we essentially have now is a coefficient of 1c. And you remember, a positive 1 is the only acceptable coefficient of a variable. Now on this side, when we do some simplifying, the 2 goes into itself once, and it goes into the 14 7 times, giving us a value of 7/5. And remember the rule of fractions, it always has to be in its simplest form. 7/5 simplifies to 1 2/5. And this is what c equals in our first example. Now here we have example 2. This is a two-step equation, and there is an awful lot going on here. So you may need to pause this a couple of times to copy what I have and then maybe listen and re-listen a few times. What I did is I have the problem on one side and I have a list of steps here on the right. Our original problem is 7/8 minus 9/10 equals a -1/8. And the very first thing that we have to do, because we're working with fractions, is we have to find the least common denominator and make equivalent fractions, because we have an operation here in subtracting, so we have to add. So what I did was I found that our least common denominator was 40. So now our new equation is 35/40x minus 36/40, and that equals a -5/40. And now what we're going to do, because you have to recognize that there are two terms keeping the x from being alone. It has a coefficient of a 35/40, and it has a constant of a -36/40. So our next step after finding the least common denominator and making equivalent fractions is to negate the constant. And we're going to do that by applying a positive 36/40 to both sides of the equation. After you do that, you simplify, and we end up with 35/40x equals 31/40, because here, this -36/40 and the +36/40 together make 0. So I'm going to add the step simplify right here. So now we have gotten rid of one term and we're only left with the coefficient. Because the coefficient, 35 over 40, is a fraction, the way to undo that and give the x its coefficient of a positive 1 is to multiply both sides by its reciprocal, its multiplicative inverse. So you see I have put 40 over 35 in parentheses on both sides of the equation. Now, we don't have to put it in parentheses. Sometimes you'll see it this way. Sometimes you'll see it with the dot. I wanted to show you both ways so that you're familiar and you recognize that they are the same. After we multiply the 35 over 40x times 40 over 35, you see, we cross simplify and the 35s cancel each other out and the 40s cancel each other out. And then over here, these 40s will cancel each other out, leaving us with 31 over 35. Those numbers are relatively prime, so the fraction is already in its simplest form. Now our last example is an area problem. We haven't had one of these in a while. Let's take a look at what we have. This is a little bit different from what you're used to. Here we have an irregularly shaped figure, and I say that because when we have a rectangle or a square or a triangle, there's a definite formula to follow to get the area. But here, this is an oddly shaped figure. So what I did was I drew a dotted line down the middle, and I divided this into two parts. We have the green, that's why I labeled it G, and the B for blue. Now this green, so what we're going to do is find the area or take each rectangle in isolation and then work with it together. So we are told that the total area of these two figures together is 1 square inch. And we are tasked with having to find the value of x. So what we're going to do is first find the area of the green rectangle. And I picked that one first because we know its length and its width. We know the two numbers that we have to work with. So right down here in green for our green rectangle, I always start with the formula. The formula for finding the area of a rectangle is length times width. Then we plug in the values that we have, 1 inch times 5/8 of an inch. And so we find that the area of the green rectangle is 5/8 of an inch. Well, now we have to take that information and make an inference or make an assumption about this second rectangle, the blue one. We know that the total area of the figures is 1 square inch. So if the green has an area of 5/8 square inches, that means the blue has to be 3/8 inches squared because together 5/8 and 3/8 make 1 square inch. So we again start with our formula, area equals length times width. But when we plug in the numbers that we know, it'll be different from the green over here. Because in the green, we were solving for the area. Here what we're doing is we have the area, 3/8 of an inch, and we are solving for the width. So length times width for this problem means 3/4 times x, which is simplified to 3/4 x. So what we have here really, after all this talking and writing and understanding, is just a one-step problem. So what we do to isolate the x is we have to multiply both sides by its reciprocal, its multiplicative inverse, which is 4/3, which I wrote in red. Over here on the left, when we multiply 3/8 times 4/3, the 3's cancel each other out, and we end up with 4/8, which I went ahead and simplified to 1/2. Here, the 4's cancel each other out, and the 3's. So we learned that this side, x, has a value of 1/2 inch. And so when you encounter problems like this, what you need to remember is divide the irregularly shaped figure into two regularly shaped figures, and then work from there.